Right, so my name is Aaron Porterfield. I'm an industrial designer from San Francisco. I've worked in additive for a really long time for a variety of companies, but that's not really what I'm talking about here. Is I want to talk about kind of how I got here. And I think I have to blame my parents for that, is because when I was a kid, they didn't buy me video games. And so I got my dad's old DOS PC with some Atari games, but it had something on it called BASIC, and I started to learn basic programming as a kid. And then when my friends were playing Tony Hawk's Pro Skater, again, I had my parents' PC. And when I was looking for free games online, I found something called Blender. And it turns out it wasn't a free game, it was a free game engine. And so that kind of made me eventually want to be a video game designer. I got really involved with Blender, and then in 2002, they kind of lost funding, and they wanted to raise money to go open source. And so they did. So I became one of the founding members of the Blender Foundation. My plans of being a video game designer didn't work out. I dropped out of high school and went to art school. And so I studied industrial design, but I didn't really fit in there either. I didn't want to spend the rest of my life drawing toasters. So I wanted to do something like more interesting with my life. And around that time, there's this revolution happening. All these open source 3D printers were coming out there's all this hype about democratizing design, decentralizing manufacturing, mass customization. And so this hype, I wanted to be part of it. And so I went on Kickstarter and I bought my first 3D printer, this RepRap. But there was kind of a step missing. I didn't really know quite what it was. And I realized to really do mass customization, you really need to make a parametric design. And so that's where I kind of found Grasshopper. Here's just a funny video of me trying to do some non-planar toolpaths on the RepRap. It didn't work out so well. So then, now that I had kind of parametric designs, I kind of needed a place to put them. And I found this website called Instructables. It's kind of a DIY website, and I started publishing projects on there. And then shortly after that, Autodesk bought Instructables, and they built this place called Pier 9 in San Francisco. And then I got invited to be an artist in residence there. So I did a variety of projects there. One was like these parametric glasses that could be printed on a simple FDM machine. And I even got an article in Make magazine, which is a huge check off my list, because I was always a huge fan of Make. But while I was there, I also just liked to play around and experiment. So I got really obsessed with these things called lattice hinges. And it's basically you can laser cut this tessellation of these patterns into a rigid material, and it creates a bunch of little torsion springs and actually makes a rigid material flexible. And so I started to try to develop scripts where I could take any developable surface in 3D and then apply the correct pattern in the correct direction and density of the pattern to get the right curvature or radius. And of course, the goal was to find this elusive double curvature from a rigid developable material, which is really hard to do with laser cutters. But then I got obsessed with origami. And there you can kind of make any surface developable. And so I started playing around with making scripts where I could apply origami tessellation and develop the flat surface. Meanwhile, at Autodesk, a friend of mine, Amanda, was developing this web-based app called Origami Simulator. And it uses this dot fold format, so I was able to export as a dot fold. So for the real origami nerds, check out the dot fold format. It's pretty cool. And so all this lattice hinges and origami tessellations obviously led into lattice structures. But I'm not going to talk a lot about that because I know everyone here is an expert and I'm not, so I'm going to skip that. But I realized this is what I really wanted to do, so I started a company called F equals F, and it stands for form equals function. I'm not going to talk a lot about my professional work, but I will talk about the stuff I really like doing. I've kind of found what I call the Goldilocks zone, and as a designer, it's where you're designing something that really makes sense for what it is, and it feels good doing it. So with orthotics and prosthetics, it absolutely makes sense for additive. Everything has to be custom made. Complexity is free. And you're changing people's lives, so it feels really good doing it. So this company I work with Nea, and Carlos here from Nea. I'm going to show just a couple projects I'm proud of is these helmets. This is for craniotomy patients. So if they've had part of their skull removed, they need a helmet to protect their skull. This is the EpiPro. It's for patients with epilepsy. So, if you're a kid, you can play on a playground and not worry about having a seizure and falling. And this is the CranioCare. It's for sculpting infant skulls back into the correct shape. But that's all I'm going to show in terms of professional work. But what I really wanted to talk about is open source stuff. And so a lot of people ask, like, what are the benefits you get from sharing open source? And the answer is nothing. You shouldn't expect anything from sharing anything open source. Maybe you get some recognition. I think that's the only reason I'm here now. I don't know what I'm doing here. But yeah, that's all. But you do meet a lot of people and make a lot of friends. So for example, this is my friend Arthur Mamamani. He found my work when he found my Instructables when he was doing this installation called Wooden Waves, where he was doing this lattice hinge kind of thing. And we became friends. It turns out he teaches architecture at the University of Westminster in London. And he has his students kind of write their thesis on this website called We Want to Learn. So it's almost like an Instructables page. And he also has his students write proposals to build projects at Burning Man, which is a festival in the desert in Nevada. And so one year he asked if I wanted to come build with him in the desert, and I said, hell yeah. So I've done that a few times now. This is like in 2015, the infinity tree, which is kind of this reciprocal structure of a minimal surface. And it was a terrible, terrible thing to build. And the other one was much nicer, Tangential Dreams in 2016. And then the last one I built with him was the Temple of Galaxia in 2018. And this one was really interesting because it was all built by about a total of 150 volunteers, and a lot of them with zero construction experience. So we had to kind of write instructables about how to actually build something. And our construction drawings looked more like IKEA instructions. So it was made as simple as possible. Just cut these pieces, make triangles, attach the triangles, a total of 2,400 triangles, or what I like to call duangles. So you can kind of see the process here, this aerial view of how we put these triangles together. And then we flew them up with a crane, and then in a couple of days we burned it all to the ground. And then, but what's most important, what's much cooler than like the design or the engineering of that project was really just the community of who put it together. 150 volunteers from all over the world just wanted to share this experience together. And that's something I really love about Burning Man, is this communal effort that goes into it. And so speaking of communal effort and ADD, I have severe ADD and I can't finish projects myself. And so what I tend to do is prototype things and then put it online for open source or free. And what's really cool is seeing people actually finish your projects. That's great. If you have severe ADD like me, people will finish it for you if you put it online. So it's awesome. So there's this company in Brazil contacted me and asked if they could make a lamp that I made, and I said, sure, absolutely. This company in New York kind of makes things for Apple products. This sculptor named Lars took this curvature thing to the next level. And this was actually using my plugin that I haven't even tested if it works. So he tested it for me and it works. It's pretty amazing. But there's this other side of open source. You know, it's supposed to be free and open source, but then I found on like Etsy, there's a bunch of people just selling the patterns online. But it has 4.9 out of 5 stars out of 3,000 reviews. So it's pretty damn good, I think. And for €3 more, you can get one named after Andreas Sebastian, my friend in Autodesk, which is pretty cool. So I wanted to talk a little bit about licenses, but I realized I really don't know anything about licenses. But for these kind of projects, Creative Commons makes sense. But what I really like about it is I think attribution is important. I don't know if it's me because of my ego or if it just makes sense because you can kind of track where things come from. And then share alike, I think, just makes sense, so that you gave the same rights to the next person. Now, how much time do I have? I'm doing okay? 10 minutes? All right. So I was supposed to talk about a lot of open source software, but the one I use most is not open source, but it's really good. It's Grasshopper. But I think what really reminds me of Blender with Grasshopper is kind of the community. And so with Rhino, you have this open API, which allows people to create a lot of different plugins, and 99% of them are free, I think, and a lot of them are open source. And the forums are just super active and with generally nice people that just want to help. And so I wanted to give back to that community, and so I made a plugin called Crystallon, and it's for creating lattice structures. It's an open source tool. It's made to be adaptable. It's all made out of clusters of all native Grasshopper components, so you can open it up and see inside and see how it's made. Just for fun, has anyone here used Crystallon? Yeah, nice, cool. Keep your hand raised if you've helped develop Crystallon. I'm just, that was a joke. So it hasn't been touched for probably 6 years. It has cobwebs on the GitHub page, but not until recently, in the last couple weeks, this awesome guy named Ian Woodward out of Washington, D.C. stepped up and said he wants to help out. And so he taught me how to use GitHub properly. He made a landing site. Now all the information is all in one place. All the documentation I've written, like I had this 65-page PDF, is now online and it's searchable. He taught me how to actually make releases on GitHub. So now this burden of like having to make a new version for people that, when's Crystallon 3 coming, when's Crystallon 3? Now it's not going to happen. It's just going to be 2.0, 0.1, 0.2, and whenever we make a new component, we'll push a new release. And now it's on the Rhino package manager, so it's easy to do. We'll push a release, and then you just go and update it. And thanks to the McNeil people, we also have a Crystallon page on the forums. How am I? Yeah. Cool. So that 6 years ago, I took this picture from my notebook of this is kind of what I wanted to do next with Crystallon, the Triangle Manifesto. I know Duane doesn't like triangles. But this kind of meant like a full rewrite of how I made Crystallon, because instead of using cubic, triply periodic kind of cube-based unit cells, wanted to be able to use wedges and tetrahedrons, things like that. And so I've started to kind of develop this, but I haven't released any of it yet. But now that it's easy to do, you'll start to see some of these coming in Crystallon. And so a few new things is it's really going to be focused on simulation and using the Calculix. It's an open source solver. Huge thanks to James Solly from Format Engineers for helping me with that. And file formats are important. 3MF, Gmesh is really good, and input decks. And if I have time, I'm going to talk about one fun little project. So I'm not an engineer. I'm not a scientist. I'm not an electrical engineer. I'm not a programmer. But I always wanted to try to make a compression testing machine because I get a lot of clients that either they have one in-house or they have a lab that they send them to, or that, but I know it's all very expensive. And sometimes I get clients that don't know what it is and don't know how expensive it is. And what I wanted to do was try to make one myself. And not knowing anything about what I was doing, I think is the best part of this project, because no one was telling me you're doing it wrong or anything like that. It was just, I had no expectations, never designed a machine before. And I tried to make it almost like a rep wrap, as cheap materials and parts as possible. So these are just load cells from a bathroom scale, NEMA 17 motors and stepper drivers. I made a little processing script to kind of read the data. And to my surprise, it actually turns out to work pretty well. And so I started testing a lot of the outputs from Crystallon, trying to kind of create a database of these cells. Sometimes I get these haters on Instagram. They say, like, why do you make them just to hurt them? And, for me, it's like lattice yoga, right? You're just trying to understand how they stretch and how they bend. Like, for example, this one made no sense to me because it really felt like it had kind of two stages of compression, but it's ended up being almost as linear as a foam. So, and since I have severe ADD, I've never even finished the project, but I did put it online. And so it's on GitHub. And if you want to help me develop it, please let me know. Let's do it. And that's all I got for you. Thank you.
Thank you. To learn more about the CDFAM Computational Design Symposium series, to see the archives of previous presentations, and to learn about future events, visit cdfam.org.